It was just a dim point of light. Then everything changed. On July 1st, 2025, a telescope in Chile caught something that should not have been there. It was moving too fast. Its path looked wrong. Within days, astronomers realized this object did not belong to our sun at all. It had come from the dark between stars. And what scientists found next made the story even stranger. Because this was not just a visitor from another system. It may have been born long before our own sun. Stay with this, because the final picture is far more unsettling than the headline. Space feels quiet when you first think about it. One sun, 8 planets, moons, asteroids, comets, everything circling in patterns that repeat over and over. Even when something looks wild, it still belongs to the same family. It still answers to the sun. But every so often, the universe sends us something that does not follow the family rules. Something that formed around another star, in another place, under other conditions, and then got thrown out into the galaxy. That is what makes interstellar objects so important. They are not just rocks or ice drifting by. They are pieces of other solar systems. They are messages written in matter. They carry chemistry from places we may never visit. And for most of human history, we never knew for sure if we would get to study one up close. Then in 2017, the first confirmed interstellar object appeared. It was called Oumuamua. It was small, odd, and deeply frustrating. By the time telescopes really focused on it, it was already leaving. It did not behave like an ordinary comet. It did not give scientists a bright, easy cloud of gas to study. It passed through like a whisper and left behind 1,000 arguments. 2 years later, in 2019, the second one arrived. That object, Borisov, looked much more like a comet. It gave astronomers more data and more confidence. But even that was not enough. Scientists still wanted more warning, more time, better instruments, a brighter target, a cleaner chance to study a real visitor from another system before it faded back into the cold. That chance finally came in 2025. The object was spotted by ATLAS, the Asteroid Terrestrial Impact Last Alert System at Rio Hurtado in Chile. ATLAS exists for a very practical reason. It scans huge areas of sky again and again, looking for moving objects that could become a danger to Earth. Most of what it sees are ordinary things, asteroids, known comets, small bodies following familiar paths. But on that night, the system picked up something that looked different almost at once. The object was faint, but its motion stood out. As astronomers started checking its path, the answer became impossible to ignore. This was not an object in a normal solar orbit. It was on a hyperbolic path, which means it was not bound to the sun. It was passing through. It had come from outside the solar system, and it would leave again forever. The object was later named 3I Atlas, the third confirmed interstellar object ever found, and the first one discovered with enough warning that the world could prepare. If you had been sitting in one of those control rooms when the orbit locked into place, imagine that moment. You are looking at a tiny speck on a screen. It seems harmless, easy to miss. Then the math tells you it crossed the huge empty gulf between stars and just happened to enter our neighborhood while you were alive to see it. That is the kind of fact that makes the room go silent. And yet the story was only getting started. Because once astronomers knew what they were dealing with, they went back through older images, and there it was again. Then again, then again. Hidden in plain sight, pre-discovery images were found going back to June 14th, from earlier ATLAS data and from other sky surveys. The comet had already been there for weeks. We simply had not recognized it yet. A traveler from another star system had been moving through the dark while humanity looked straight past it. That alone would have made this a major story. But what the object later revealed about its chemistry turned it into something much bigger. At first, 3I Atlas looked like the kind of discovery astronomers dream about and dread at the same time. Dream about, because it was rare. Dread, because rare things vanish quickly. Yet this time, there was a gift built into the timing. Scientists had months before the comet reached its closest point to the sun. That changed everything. Back in the Oumuamua days, teams had to react almost in panic. This time, they could plan. They could schedule. They could argue over telescope time and still get it. Ground observatories across the world started tracking the comet. Orbit specialists kept refining its path, and the numbers stayed strange. The comet was on a steep, incoming route, cutting through the solar system at a dramatic angle. It was not looping like an ordinary body born around our sun. It was slicing through on a one-time visit. It posed no threat to Earth. NASA made that clear very early. It would stay far away, with its closest distance to Earth still around 1.7 to 1.8 astronomical units. That is roughly 270 million kilometers. Far beyond the moon, far beyond any near-miss story. So if this was not a danger story, what was it? It was something better. It was a pure science story. A chance to study matter from another star system while it was still active and bright enough to reveal itself. As the comet moved closer to the sun, Heat began to wake it up. Ice inside the object started turning to gas. Dust escaped. A glowing coma formed around the nucleus. A tail appeared. And that was wonderful news for astronomers. A quiet rock keeps its secrets. An active comet leaks them into space. Gas and dust become evidence. They become fingerprints. Suddenly, the question was no longer just where this object came from. The question became what it was made of, and whether that chemistry looked anything like the chemistry of comets born in our own system. Hubble soon joined the effort. Images from the Space Telescope showed a teardrop-shaped cocoon of dust surrounding the hidden icy core. Even estimating the size of that core was difficult, because the bright material around it made direct measurement hard. Early limits suggested the nucleus could be as small as a few hundred meters or as large as a few kilometers, with upper estimates around 5.6 kilometers across. That range may sound messy, but the big point was clear. This object was active. It was visible. It was worth chasing with every tool we had. And the closer it came, the more pressure built around a single name. James Webb. If you follow space news, you know what that name means. Webb is not just another telescope. It is the most powerful infrared observatory humanity has ever built. It sees wavelengths our eyes cannot. It can separate light into detailed spectra that reveal what molecules are present in a distant target. It can look at as gas around a comet and tell scientists what is actually there. Water, carbon dioxide, methane, other compounds. It reads chemistry through light. That made it the perfect instrument for 3-eye atlas, at least in theory. In practice, there was a problem. Webb was not designed around the idea of chasing a small, fast object whipping through the solar system. It lives far from Earth and tracks targets with extreme precision, but this kind of moving target pushes the system hard. Engineers and scientists still made it happen. That tells you how important this comet became. And if you are wondering what you would have done with that telescope time, ask yourself this. Do you point the most valuable observatory on Earth at a tiny object from another star system when it might vanish and never return? Or do you play it safe and keep the schedule unchanged? Most scientists did not hesitate. You take the shot. You always take the shot, because these moments do not come often, not in a career, maybe not even in a lifetime. And this is where the story takes its first real turn. The more data that came in, the less this looked like a routine icy wanderer. It still behaved like a natural comet. It still looked like one. But its deeper chemistry began to hint at a formation history that was colder, older, and more alien than many researchers expected. Not alien in the way internet rumors use the word. Alien in the only way that really matters to science. Born somewhere else. Shaped by another environment. Carrying a record of a time and place beyond our own cosmic backyard. Before we get to what Webb saw, hold one question in your mind. If this object really spent billions of years drifting between stars, what should have survived on or inside it? That question sits at the heart of the entire mystery, because the answer was not what many experts expected. Webb observed 3-eye atlas after its close pass by the sun, when the heat had stirred up fresh activity and the comet was releasing material into space. That timing mattered. Sunlight had warmed the object enough to expose deeper layers, but not so much that everything was lost in chaos. It was the perfect moment to sniff the escaping gas. And Webb did exactly that. In one of the most important results from the whole campaign, NASA announced that Webb had directly detected methane on an interstellar visitor for the first time. Stop there for a second, because that one sentence carries far more weight than it seems. Methane is a volatile molecule. It turns from ice to gas very easily. Over very long periods, especially under radiation in interstellar space, it should be hard to keep near the surface. So when Webb found it around 3-eye atlas, scientists had to think carefully about what that really meant. The simplest explanation was also the most powerful. The methane Webb saw may not have been sitting on the outside all those billions of years. It may have been hidden deeper down, protected beneath the surface, shielded from the harshest damage until the sun heated the comet enough for that buried material to escape. In other words, Webb may have been reading ice that had been sealed away since the object first formed. Not last century, not before human history, possibly before our sun even existed. NASA also said the comet remained unusually rich in carbon dioxide compared with water when set beside typical solar system comets. That alone suggested a very different formation environment from most of the comets we know. Different temperature, different chemistry, different history. Then the picture grew even stranger. A later Webb study, released with European Space Agency support and published in Nature, pushed the implications further. Researchers using Webb found extremely high levels of deuterium, also called heavy hydrogen, around 30 times what is seen in solar system comets. They also found very low amounts of carbon-13 compared with carbon-12. If that sounds technical, here's the simple version. These are chemical clues that help scientists work backward. They act like weather stains left on the object by the environment where it formed. High deuterium points to very cold conditions. Low carbon-13 suggests great age because stellar systems become richer in carbon-13 over time as generations of stars live and die. Put those clues together and the comet seems to point toward a place that was deeply cold and very old. That is why researchers said 3I Atlas probably predates our sun and solar system. Some estimates suggest it could have formed 10 to 12 billion years ago during a much earlier era of the galaxy when star formation was raging across the universe. Think about that scale. Our solar system is about 4.5 billion years old. This comet may have begun its story long before Earth existed, long before the sun was born, long before the solar system took shape from its own cloud of gas and dust. If that estimate is even close, then 3I Atlas is not just another comet. It is a frozen survivor from a time when the galaxy looked very different. It may have formed around a star system that no longer exists in anything like its original form. It may have been thrown out into deep space by the gravity of giant planets, or close stellar encounter, or some violent shift in its birth system. Then it spent unimaginable ages drifting in darkness. No sunrise, no seasons, no warm world nearby, just cold, radiation, and time. Endless time. Then, by chance, it wandered close enough to our sun for a few months of activity and observation before continuing on. This is the part where many stories online jump too far and too fast. Some people heard ancient chemistry and started talking as if scientists had found proof of something impossible. They had not. What they found was better than hype and more valuable than rumor. They found real evidence that another planetary system produced icy bodies under conditions unlike the ones that shaped most comets here. That matters, because it turns a guess into a measurement. It tells us the galaxy may be full of chemistry that does not match our local norms. And if you are still with me, this is the moment to ask yourself one thing. If one interstellar comet can carry chemistry this different, what else is moving through the dark unseen right now? What other frozen archives are passing through our system before we ever notice them? That question only grew larger as other teams joined the story. Ground-based studies with the Very Large Telescope added carbon and nitrogen isotope measurements that supported the idea of a very unusual origin. More observations continued to map the comet's behavior as it moved away from the sun. Every new layer pointed in the same direction. This was not an ordinary comet that merely came from somewhere else. It was an object that preserved signs of an environment far older and colder than the one that produced our own familiar icy bodies. And once scientists understood that, the story changed from discovery to confrontation. Not a confrontation with danger, but with perspective. Because 3I Atlas was quietly asking a hard question. How normal is our solar system, really? Scientists love strange data, but they are careful with it. That is part of what made the response to 3I Atlas so interesting. You could feel the excitement in the official language, but you could also feel the restraint. Researchers at NASA Goddard and their partners did not say they had solved every mystery. They said this object gave direct insight into a distant time and place and might teach us how unusual our own solar system is. That sentence matters. Not how exotic the comet is by itself, but what it says about us. We have one sample set we know well, our own system. We sometimes act as if it is the standard pattern for the galaxy. Then, an object like this arrives and reminds us that our standard may only be local. Maybe methane-rich interstellar comets formed in very cold birth clouds are common in older parts of the galaxy. Maybe the chemistry that built our neighborhood is only one version of a much bigger cosmic menu. Even the comet's likely age carries a lesson in humility. If 3I Atlas really formed 10 to 12 billion years ago, then it was already ancient when the material that would become Earth was still unassembled dust. That means our instruments were not just studying a foreign object. They were studying a relic from an earlier chapter of galactic history. A body born when star formation in the universe was at a furious pace, a body that may have locked away pristine material from that era and delivered it to us by pure accident. Of course, not every detail is settled. Scientists still debate exactly how to model the object's past, how to interpret each ratio, how deeply heating reached into the comet, and how much its surface changed during its long journey. That is normal science. The real signal here is not that everyone agrees on every decimal place. The real signal is that independent lines of evidence keep pulling toward the same broad conclusion. Old, cold, different, and natural. That last word mattered too, because once any interstellar object appears in the news, part of the internet begins asking the same question. Was it artificial? Was it built? Was this some kind of probe? Scientists did not ignore that question. The Breakthrough Listen team and the SETI Institute used the Allen Telescope Array to observe 3I Atlas across a wide radio range only days after discovery. Later, observations with other facilities continued the search. No technosignatures were found. No artificial radio emission was detected. Signals that looked interesting at first were traced back to ordinary human interference. The object behaved exactly the way a natural comet should. That result is important, but not because it kills the story, it sharpens it. We do not need fantasy here. The truth is strong enough on its own. A natural comet from another star system, maybe older than the Sun, carrying chemistry, unlike the comets we know, drifting into view for one brief season and then leaving forever. That is already astonishing. And if you care about life in the universe, this story still matters deeply. Not because it proves life elsewhere, but because it touches the ingredients and environments that come before life. One of the researchers involved in the Webb work said the bigger picture was about prebiotic chemistry elsewhere in the galaxy. That means the chemistry that can someday feed more complex systems. We know one place where chemistry led to life: Earth. We do not yet know how common those conditions are. Objects like 3I Atlas help us test that question by giving us direct samples of how chemistry unfolded under other circumstances. Not in a lab, not in a computer simulation. In reality, out there. If that sounds abstract, bring it down to a human scale. Every person alive inherits an old question, whether they think about it or not. Are we looking at a universe that tends to build the same kinds of worlds again and again, or are we the product of a very unusual path? Each strange visitor from interstellar space pushes that question a little further. Each one widens the map. Each one reminds us that our cosmic home may be only one version of what a planetary system can become. And if you're enjoying this kind of grounded mystery, the kind that gets stranger the more real it becomes, you already know why people keep coming back to stories like this. The universe does not have to shout to unsettle us. Sometimes it only sends a silent piece of ice through the solar system and lets chemistry do the talking. What makes the 3I Atlas story even bigger is what it suggests about the future. For a long time, interstellar objects felt almost mythical. One appeared in 2017, another in 2019, then a third in 2025. 3 in less than a decade might not sound like much, but astronomy is not just about counting. It is about what your tools can actually see. Surveys have become faster, wider, and more sensitive. The sky is no longer being checked in the old slow way. It is being scanned with relentless repetition. That means some of these visitors may not be rare at all. They may be passing through the solar system all the time, too faint or too early or too poorly placed for older systems to catch. 3I Atlas may be important not only because of what it was, but because of what it hints at. We may be entering an era when interstellar objects stop being freak events and start becoming a new category of routine discovery. Not routine emotionally, never that, but routine scientifically. A future where astronomers expect these arrivals and prepare for them. A future where the next visitor is found even earlier, studied even better, maybe even intercepted by a spacecraft if we plan far enough ahead. That thought changes the whole mood of this story. Instead of one haunting accident, 3I Atlas becomes a preview. The Vera C. Rubin Observatory and other next-generation surveys are expected to increase discovery rates for faint moving targets. More warning time means better observations. Better observations means stronger chemistry, tighter orbits, sharper size estimates, and fewer wild guesses. One day, it may mean a mission designed to chase one of these bodies and sample it directly. Picture that for a moment. Humanity launching a probe to meet a fragment of another solar system as it sweeps through our own. That is no longer science fiction in spirit. It is a real planning question. And the reason is simple. Interstellar objects are free samples from the galaxy. We did not have to leave the solar system to reach them. They came to us. That is why so many telescopes joined the effort around 3I Atlas. NASA missions, European observatories, ground arrays, space telescopes, teams in different countries working against the same clock. The comet would not wait. It would warm, brighten, swing around the sun, then fade and leave. So the world moved fast. That coordination is one of the quiet triumphs of the whole event. We talk a lot about giant discoveries as if they emerge from one machine or one genius. In truth, stories like this are built by networks of people watching the same object with different eyes. One team refines the orbit, another measures dust, another studies spectra, another tests for radio signals, another compares isotope ratios. And slowly, a single picture emerges from many fragments. That picture in this case was both simple and profound. A natural comet from beyond the solar system entered our neighborhood. It carried chemistry that points to a birth in a very cold and probably very ancient environment. It gave off methane, strong carbon dioxide, heavy hydrogen, and unusual carbon clues. It seems to preserve material from a distant chapter of galactic history. Then it continued on its way. No drama, no explosion, no cosmic attack, just truth, which is often stranger than spectacle. Now zoom all the way out. Somewhere in the Milky Way, countless star systems have formed, changed, collided, and died. Giant planets have scattered smaller bodies into deep space. Passing stars have disturbed distant clouds of ice. Some of those bodies have wandered for billions of years with no home at all, and once in a while, one of them enters the same sky as Earth. We look up at what seems like empty darkness, but that darkness is not empty. It is full of histories in motion, full of unfinished journeys, full of objects that began around other suns and may outlive the stars that made them. That is the deeper secret here. Not that 3i Atlas was weird, but that the galaxy is likely full of such wanderers, and we are only now becoming able to notice them, which means the sky above us is even less familiar than we thought. Not just far away, foreign. At some point, long before the sun lit up this system, 3i Atlas was probably part of a young and distant family around another star. Maybe it formed in the frozen outer reaches of that system, where weak light and deep cold allowed unusual ices to build. Maybe giant planets stirred the region until one close gravitational shove changed everything. Maybe a star passed nearby and pulled on the system's edges. However it happened, the result was the same. This small body was thrown out, cut loose, sent into interstellar night. That might have been the end of the story for almost anything that ever knew it, but not for the comet. It kept going, year after year, million after million, billion after billion, through regions where no sunrise came, through distances so large that human language barely holds them, through a galaxy changing around it, new stars being born, old stars dying, entire systems rising and fading while this one cold object continued drifting in silence. Then, in a moment so brief it would barely register on its own timeline, it passed through ours. We saw it. We named it. We studied the gas that sunlight pulled from its ancient ice. And from those escaping molecules, we learned that the object may be much older than the world that studied it. That is the kind of story space does better than anything else. It makes you feel both tiny and lucky at the same time. Tiny, because the universe is full of journeys that began long before us and will continue long after us. Lucky because we happened to build the right telescopes in time to catch one of them. A few centuries earlier, this comet would have passed with no real explanation, a dim blur, if seen at all. A few decades earlier, we might have found it too late to do meaningful chemistry. But in 2025 and 2026, humanity had Atlas scanning the sky, Hubble watching from orbit, Webb reading infrared fingerprints, radio arrays testing strange ideas, and teams ready to work together fast. That is why this story matters. Not only because the comet was extraordinary, but because it shows what our species can do when patience, engineering, and curiosity all line up at the same moment. And we are still not done. Researchers continue to analyze the data. More papers may refine the age estimates, the isotope story, and the full meaning of the chemistry. Some claims will get sharper, some may soften. That is how science stays honest, but the central truth is already solid. A real interstellar comet entered the solar system. It was active enough to study in detail. Webb and other observatories found chemistry that points to a very different formation environment from the one that shaped most of our comets, and the object may carry material from a time long before the birth of our sun. If that does not change the way you think about the night sky, think about it one more time. Somewhere out there, beyond the planets and beyond the local stars, more of these bodies are moving right now. Ancient, frozen, unannounced. Some will pass by unnoticed, some will arrive too faint for us to catch, but some will be seen. And when they are, each one will bring another chance to compare our story with the larger story of the galaxy. So the next time you look up, remember this. The darkness above you is not empty. It is crowded with old travelers. Some were born before Earth had oceans. Some may carry chemistries no human has ever measured. And once in a very great while, one of them crosses our path and lets us ask the oldest question in a new way. What kind of universe made us, and how many other ways are there to make a world? If this story pulled you in, that is because the mystery is still open. Not whether 3i Atlas was real. It was. Not whether Webb found something unusual. It did. The open mystery is larger. How many ancient relics like this are out there, and what will the next one teach us that this one only began to reveal? That is the part nobody can answer yet, and that is exactly why we keep watching. Webb found an ancient interstellar comet, and its chemistry should not exist here. NASA just tracked a visitor older than the sun, and scientists are stunned. 3i Atlas entered our solar system, and what Webb found changes everything.